All right, so let's remember what the trig functions look like, and then we'll get the inverses. So first things first, what's your favorite trig function?
Sine.
Sine? Okay. So sine's the one that looks like this, right?
Yeah.
I need a giant stencil. Okay, so giant.
Yeah, just piece of
It'd be hard to 3D print ones. I have little ones though. If you guys want them, we should print some. So about this, what does this fail right now, and why is that a problem?
horizontal, and that's the whole reason why you're teaching this.
Yeah. Okay, good. This fails the horizontal line test, right? You guys all see that?
Yeah.
Okay, so what I'm going to do with this thing is
Restrict the domain.
I'm going to restrict the domain because I need an inverse for this sucker. And I know I'm not going to be able to find one. So where are you going to cut this thing so that it passes the horizontal line test?
Highest point, lowest point.
Okay, so you need to cut from a trough to a peak, right?
Do that.
And which trough to peak do you want? Do you want this one?
The one that goes right into the peak.
Yeah. Hell no. Pick the good one, right? So pick this one.
Yeah.
So we're going to cut there, and we're going to discard this chunk of the function and that chunk of the function. Pitch, pitch. Cool? So I'm going to end up with something that looks a little bit like sine, but isn't actually sine. And then we're going to invert that. You guys cool that? Okay, so this little piece of sine is going to be like sine bar or something, right? Like I can name it whatever I want. It came from sine, so I'm going to call it sine almost. And what's the difference here? This thing is sine, right, of theta, except for what?
Anything more than pi over 2 and less than negative pi over 2.
Yeah, perfect. So this thing means some kind of condition applied. So I'm going to apply the condition that theta be between where and where?
Negative pi over 2 and pi over 2.
Okay, so we're going to go from negative pi over 2 to pi over 2. You guys cool with that? And now this function has an inverse. Cool? So I'm going to define this little symbol, sine inverse, right, of, should I put a theta in here?
No,
Why not?
because they got apply standard.
Because you're born with
trying to get an angle out of it instead, so you have to put numbers in.
Yeah, you guys see that? Right? Sine usually takes angles and turns them into opposite over hypotenuse, right? So on this one, I should put an opposite over hypotenuse in and get an angle out. You guys see that? So I definitely shouldn't think about feeding thetas in here, because this thing doesn't take angles, it takes ratios of lengths. You guys see that? Okay, so I'm going to call this sine inverse of x is, and that's going to be the inverse function of sine bar of theta. You guys see that? This was kind of a cheap trick, right? So maybe I should write down the domain and range of these two things before I forget. Okay? So sine inverse is going to take what to what? It's going to be some kind of domain, right?
Yeah. Negative pi over 2 to pi over 2, right?
No.
Ooh. Ooh.
No, that's range.
Is that the range?
Yeah, that'll be the range. Why will that be the range?
Because it flips.
Oh, you flipped your x and y.
Yeah, because this will be the unfunction, right? And these are the inputs
One to
for the
negative
forward function. So they'll be the outputs for the backwards function.
So between 1 and negative 1?
Yeah.
So this is going to take things between, what did you guys say?
1 and negative 1.
1 and negative 1. So we're going to go the closed interval from negative 1 to 1. That's the domain. And the outputs we're going to get are the closed interval.
That's the negative pi over 2.
Yeah, and that's the negative pi over 2, comma pi over 2. You guys cool with that? Okay. The thing I want you to think about this guy, like punchline, is put these domains and ranges in your head and think to yourself, where do those angles live? Where do these angles live on the unit circle? They're the,
Oh, they're the right half.
yeah, these are the right half of the unit circle. You guys see that? So sine inverse is the right half of the unit circle.
Oh, shit, that's right.
You guys cool with that? The answers are always good. Like if you type sine inverse of something with your calculator, the number it gives you is always going to be right hand side of the unit circle. Cool with that? All right, so let's play the same game with cosine. It'll be faster this time because we've already played it with sine. Okay, so we're going to get out our cosine graph. Oops. Oh, I should do this in a different color. Okay, so we get out our cosine graph. Perfect.
They can't see me back
Can't see blue at all. Okay, so we get our cosine graph, which starts where?
High point.
Starts with a peak here. Oops, shit. Too steep.
Just sine shifted over.
Yeah, which is just sine shifted over a bit. So now where do you restrict?
Beginning to
That to trough.
pi.
Yeah, so you need to go from a peak to a trough again, right? And which spot do you want to include and which way do you want to go?
To the right.
So you probably start at this peak, right? And then you want to go right. Because I want the angles to be positive, yeah? Okay, so I'm going to cut here and there, and we're going to pitch this stuff, and we're going to pitch this stuff. Right? So I'm going to make a little function that's going to be, oops. I'm going to make cosine bar of theta, right?
Right.
Which is going to be cosine of theta restricted.
From 0 to theta to pi.
Perfect. Thetas live between 0 and pi, right? And now this function I can invert. You guys all see that?
Mm-hmm.
Okay, so I'm not even going to write down this thing about it's the inverse of that because you guys are on that, I think. Where are its domain and range? So cosine inverse is going to take, what's the domain?
-1 to 1.
Good, cool. We still get a whole, right, trough to a peak,
Yeah.
-1 to 1. And it's going to turn that into where are the angles going to live when I get outputs.
Between 0 and pi.
Good, they're going to live between 0 and pi. Okay. Which means,
So then the top two quadrants.
yeah, cosine inverse lives in the top two quadrants. You guys cool with that?
That makes sense.
So cosine inverse and sine inverse, they both work in quadrant 1, right? Like they'll both give you an answer if things are in quadrant 1, but they'll give you conflicting answers. You guys see that? If things are in the 2 and 4 quadrant. You guys see that? So if they give you answers that seem a little funny, you need to remember this thing about the unit circle. And then you can chase down the answer you want by reflecting in the appropriate direction. You guys see that? And you're kind of shit out of luck finding something in the 3rd quadrant, right?
Yeah.
You're going to have to reflect from both things. Cool? All right. How's tangent inverse work? Let's get that one quick while we're here. 4th. It's actually not bad. Tangent inverse is a bit better.
When I learned this, they just told us to like memorize all of the identities. Like they gave us a sheet and told us that they lived in these quadrants, and like you just memorize all of them, and then we did problems on it.
Yeah,
kinda
I can't remember that much stuff.
Yeah, it was.
And so I try to give you guys the way to get this stuff instead of remembering it all. It might not be a bad idea to memorize all of this, but I don't think you have to do that. Let's see, so tangent inverse, where to where? Okay, it's the zebra stripey thing. Okay, so like there's one of them, here's another one. Oops, that's really bad. Here's another one. That one's really bad too. It's good, I'm gonna throw those away. So which one am I gonna keep?
Middle one.
The one 7 over? Right? No, screw that. Keep the one in the middle. So pitch the rest. And then, do I have to cut it in half? No.
Because it passes.
One of the zebra stripes will pass the vertical line test all by its lonesome, right? Okay, so after we restrict, we'll do this thing, right? So let's figure out tangent inverse. Tangent inverse is pretty chill. So tangent inverse is going to take values from,
Negative, negative, positive.
ooh, cool. Tangent inverse is very nice, right? It takes all of R as input values and it turns it into what?
Into anything between negative pi to, excluding those.
Oh, this one's different, right?
Parentheses. Yeah.
These are parentheses, not closed brackets, because those two values can't come out of tangent inverse. Why can't they come out of tangent inverse?
Because
Because they're the asymptotes, right? They're the spots that you get division by 0 with the tangent function. You guys see that?
Yeah.
One really cool thing here is that tangent inverse, taking R to a little open interval that's in that, means that there's as many things in the real numbers as there are in here, and there's as many things in here as there are in the real numbers. You guys see that? Infinity's weird and squishy sometimes. Cool. That's actually a trick worth knowing. Like, I kid you not, if you don't understand arctangent, you're going to have a rough time in math class. All right. Where does this thing live on the unit circle then?
on the tangent line.
No.
Okay, so that, like, where are the answers I can get out of this thing?
Oh, the whole
The
circle.
whole, well,
Yeah,
the
everywhere.
first
The whole
goes
circle
side
except for
side.
the-
Remember, the thing I'm
Cosine.
drawing here, right,
Cosine.
is the answers. So this guy will give you the same answers as sine inverse, right, except it can't obtain the ends. You guys see that? So this guy here, tangent inverse, right? The answers from that are always going to live in the right-hand side. I did have to restrict the domain, right?
Yeah.
And when I restricted that domain, I cut a big chunk off. That would be these guys in here, right? Those halves of those two zebra stripes are the rest of the unit circle.
So I have a question. If
Yeah.
you, for some reason, decided to section off a different one besides the middle,
Mhm.
would that change, where you're gonna get your answer
Yep.
on the unit circle?
Yeah, it might.
Okay. But I mean, if you choose one that's that's all negative, for the domain,
So if
like the
I
one on the left.
if I choose a whole stripe here, those are going to be the right-hand sides. But I don't have to choose a whole stripe. I could choose half of one stripe and half of another one. And that would do something else bizarre, right? Then I could do
Yeah.
the left-hand side. You guys cool with that? Like, the fact that I picked one stripe was not special. I just needed it to pass the horizontal line test. So I could have cut at 0 and said, okay, all this stuff, and then I need all the negative stuff, so I could do that stuff over here. So I could have cut here and here instead. Included a horizontal asymptote in the middle. That'd be kind of weird. It'd be a really dumb way to do things, but you could. And then you'd get like the top half or the bottom half or something. So, cool? Questions, Steels? All right, the only other thing I want you to know is a pronunciation thing. Oh, and a word of warning. Sine inverse, you can say sine inverse, the way I've been saying it. Or you can say, arc sine.
Oh.
Right, so that's the arc whose sine is. right? This one you would say as, yeah, you'd say cosine inverse or arc cosine. And this one you would say arctangent or tangent inverse. I'm going to tend to say sine inverse, cosine inverse, and arctangent. Because I'm an idiot, I don't know, but that's the way I say things. You don't have to do that. You can say them all as whatever inverse, or you can pick and choose whatever. Cool? Just know those are the same thing. The other word of warning is that, and I should write this in giant red letters, but my red marker's dead, so I'm going to settle for giant. Okay, warning. Sine inverse of x is not the same thing as sine of x negative 1.
Yeah,
That'd
Cool.
be-
yeah,
That'd be cotangent. Or
cosecant.
Yeah,
secant, that's-
this is cosecant, right? And
Yeah.
this is the unsigned function. Cool? That's actually one of the reasons that in some textbooks you'll see this.
So you don't get confused.
Yeah.
Yeah.
So instead of writing sine to the negative 1, they'll write arc sine. You see that? This is a weird thing and I have no good reason for it, but this is pretty common notation. I just want you to know that this number here between the sine and the argument is a power except when it's negative 1, in which case it's the inverse function. You guys cool? Sorry on behalf of the people who developed this. I don't know quite why we did that, but it wasn't good. Cool? Questions, things?